So our final section in this topic then is approximating using our binomial theorem. So at the end of the last video we looked at what the binomial theorem was. Here we're going to look at how we can use that to help us approximate. Okay, so first example, we want to use the binomial theorem to calculate 1.02 cubed to 3 decimal places. So what we're doing here is we're thinking about this as 1.02 cubed as 1 plus 0.02 cubed. What we're going to do is we are going to expand it out using our binomial theorem. So we've got that then being 3, choose 0, lots of 1 cubed, plus 3, choose 1, get ahead of myself there, lots of 1 squared, times 0.02, plus, now we've got 3, choose 2, lots of 1, 0.02 squared, plus 3, choose 3, lots of 0.02 cubed. And so that gives me 1 plus 0.06 plus 0.0012 plus 0.00008. And so remember, we only want it to 3 decimal places, and so that gives me 1.061. Okay, and so from that we can see that as we were working it out, a lot of that wasn't actually required. So we're only going to 3 decimal places. A lot of the detail there that we've given is too much. Okay, it hasn't actually added anything because it's been too small to make any kind of a change. So 2, let's think about another one. Let's calculate 0.9 to the power 7 to 2 decimal places. I'm going to use binomial theorem, but we're going to spell it better than that. Binomial theorem. So again, when we're looking at this, we are going to think about this 0.9 to the power 7 as 1 minus 0.1 to the power 7. And so that is going to be equal to 7, choose 0, lots of 1 to the 7, plus 7, choose 1 to the 6, minus 0.1, plus 7, choose 2, lots of 1 to the 5, minus 0.1 squared, plus 7, choose 3, to the 4, minus 0.1 cubed, plus 7, choose 4, 1 cubed, times minus 0.1 to the 4, plus 7, choose 5, now we've got 1 squared, minus 0.1 to 5, plus 7, choose 6, 1, times minus 0.1 to the 6, plus 7, choose 7, lots of minus 0.1 to the 7. Now, when we're looking at this, we've done this just for the completion of having done it all. But if we're only going to 2 decimal places, then actually we didn't really need to continue after our power of 4 when we're looking at our minus 0.1, because that's going to give us something that's going to be far beyond it and actually isn't going to make any difference to our answer. So just like in the previous one where we made it all the way as far down as we could, it gave us a really small decimal and that was fine in terms of accuracy. But we've already said in the question that we just need to be as accurate as that. So we can extend it to 3, even 4 decimal places in our working, but as soon as we start dealing with numbers that are in terms of 5 and 6, it's going to be too small to make any kind of difference to our answer, And so actually you can just leave them out. And so one of the things when you're answering these questions you can show is that you don't need to use all of these. Okay, when you're asking to work these out, well, you could just turn to your calculator for this anyway. Okay, we're going to use this again in a topic further down the line, so I know it seems trivial because you need to use your calculator. Why didn't you just put it in your calculator in the first place? We're going to use it later, but you want to avoid doing any more work than you have to do. So all these things kind of further down the line, we could have just avoided them. So actually, if we want to add them up, we've got 1 minus a 0.7 plus 0.2, 1 minus 0.035 plus 0.0035, and anything beyond that is going to give me something too small to make a difference. I don't need to bother with it. And so that gives me 0.48. That's my answer to 2 decimal places.